Okay, so let's start. Bismillahirrahmanirrahim. Assalamu alaikum and welcome to the lab number 5 of basic electrical engineering. In this lab, what we will do, we will perform the short circuit and open circuit test of a single phase transformer. So what are objectives of this experiment? In this experiment, students will learn the concept of standard testing of a single phase transformer. Firstly, the output is open circuited and the input current and power is measured. Secondly, the output is short circuited and the input current and power is measured. Results are then investigated by graph. So let's discuss the losses in transformer. So in transformer, there are power losses due to resistance of the winding and also due to the magnetic core. So resistance in the winding and magnetic core results to losses in transformer. So now what are these losses basically? So the loss in the magnetic core is known as the core loss or iron loss, because the magnetic core is made up of iron or some steel or laminated steel. And these losses are further divided into two types, which are hysteresis losses and eddy current losses. Okay. Then core losses, they do not depend on the electrical load. It means that if the load changes on the transformer, the current through the secondary of the transformer is varied, there is no effect on the core losses. So it means that core losses are constant throughout the operation of the transformer. So doesn't matter if the transformer is on no load or the transformer is on full load, the losses will be same. The core losses will remain the same. Then the second type of losses are the power losses, which are due to resistance of winding. So these are called I square R loss or winding loss, because these losses are actually because of the winding of the transformer. Okay, so next, these losses are also variable. So I square R losses are variable because there is when there is change in the load current, then there is change in these losses, and these are related directly to the heat produced in the winding. So and heat and resistance are directly proportional to each other for a conductor. So more heat is produced, more and more heat is produced, then more and more losses will be there, I square R losses in the transformer. Okay, now how do we estimate these losses? How can we measure, or how can we simply estimate these losses? So there are two methods. One is the open circuit test and other is the short circuit test. Okay, I will also look around if anyone has any questions. So far there are no questions. Okay, so let us discuss the open circuit test. So as you can see the diagram over here, the open circuit test, in open circuit test, what we do, we supply a rated voltage to our transformer, the primary of our transformer, which means that mostly in Pakistan most of the transformers are rated at 220. Okay, so 220 volts. I will just write down it here. So what we do, we connect the primary of our transformer to a rated voltage, which is generally 220 volts. So this 220 volts, 220, just mouse is not working that too well. Okay, so we connect our primary to 220 volts, and then we measure the current and we measure the watts on this transformer. The secondary is open circuited. Now connecting a voltmeter doesn't mean that we have some load on this transformer. Connecting the voltmeter means that it's a open circuit because the resistance of the ammeter is very high. Okay, so Muhammad is asking a question that, sir, why transformer has 220 volts in Pakistan? Actually, Muhammad, there are multiple configurations for okay, so just mute. Okay, so Muhammad, there are multiple configurations for power of electrical supply, and the one we are using in Pakistan is 220 volts and with 50 hertz frequency, and the one the Americans or the Japanese, they are using 110 volts. So these are the standards. So these are actually the standards which you have to practice, and as you see that every equipment you purchase from the okay, walaikum salam, Wakar keh, assalamu alaikum, walaikum salam, Wakar. So every equipment you purchase from the market, it is rated at 220 volts. So it's a standard all over Pakistan for 220 volts. Okay. So it doesn't mean that you always have to connect this input to 220 volts. You can connect this input according to the rated voltage. Now if it's a big transformer, it's a power transformer. So for a power transformer, you will see that there are 11 kVs. Okay, so it can be any transformer, any rated value of that voltage. Okay, so I have to mute mics. Okay, so those who have joined now, you can just type your questions in the chat, or just you can write here that you have a question, and we will take your questions. Okay, then you can open your mic and ask the question. Kareem is typing. Okay, so for core losses, what we need to do, we need to do open circuit test for core losses. The transformer is connected to a rated supply and the secondary winding is kept open. The power consumed by the transformer at no load can be taken as core loss of the transformer. Now what will happen, that you will see that the secondary of the transformer is open circuit, means there is no load connected to your transformer, but still there will be a power loss. There will be a power which you will see on this wattmeter. Now this power is of no use. You have not connected any bulb or fan or any kind of electrical load to the secondary side, but some power has been consumed in this wattmeter. So the power consumed here is due to the losses in this core. And by the way, in the symbol of transformer, this is the primary, this is the secondary, and this part is the laminated core. Okay, so this is due to the power consumed by a core. And in the core losses, we have discussed earlier that we have hysteresis losses and we have eddy current losses. Okay, so in the previous slides I have shown you that the core losses and iron losses, and then this core losses, this core loss is composed of hysteresis loss and eddy current loss. Okay, then we come towards the short circuit test. So In the short circuit test, we first of all we will lower this voltage. Now this is V minimum. We will minimize this voltage, and this condition here on the secondary is a short circuit because ammeter has a very low resistance. So we will short the terminals by means of a ammeter, and we will increase this voltage. V minimum will be increased slowly so that the secondary of the transformer will have a what you can say a low rated current flowing through it. Okay. Also, one thing more, that for open circuit test, the primary it will be actually the high voltage side, and the secondary will be low voltage side. We will give a 220 volts here. But for the short circuit test, the primary will be low voltage side and secondary will be high voltage side. This is due to the fact that ओके जी, मोहम्मद कह रहे हैं सलाम सर जी, वालेकुम अस्सलाम. Okay, so I have to mute the mic of Burhan. Yes, he has also joined. Okay. So now for the short circuit test, the primary will be actually your low voltage side and secondary will be high voltage side. So this is due to the fact that the low voltage side has more capacity of carrying the current. So therefore what we do, we connect the low voltage side to the primary for short circuit test. Okay, so remember this. Okay, so the apparatus is simple. We just need a single phase transformer instrument panel containing the ammeter, voltmeter, wattmeter, rheostats, variable AC power supply and connecting leads. Now this is what your panel looks like in the in your lab. Okay, so first of all you have a this is your miniature circuit breaker, which is actually has a current protection, and also it is used to turn on and turn off your panel. Then you have a variable power supply. This is the variable power supply, and using this knob you can vary the AC power, and below here you can see the connections. Here we have a fixed power supply as well. Then this is your transformer in the center. This is the high voltage side. Yes, this is the high voltage side, and this is the low voltage side. The high voltage is rated at 220 volts, and the low voltage is rated at 50 volts. Okay, so next we have a variable load over here. Okay, so the variable load actually we used it in the for the voltage regulation, and we put some load on this transformer in the last experiment. And then you can see some voltmeters and some ammeters here, and this is your wattmeter. You will see that all these meters will be having two terminals each for volt and for amperes, but in the case of watt, you know that power is equal to the product of current, voltage and current. So therefore you have a coil which measures the voltage, the potential coil, and then you have another coil which measures the current. Okay, so what is the procedure? Okay, so Mohammed, I have read your question. We will discuss it after the class, as it is not related to the class. Okay, the other question is, sir, why Mohammed sir, why we don't use multimeter instead of all these meters? Yes, we can, and we will use multimeter. So multimeters can be used for measuring. If you are using a digital multimeter, so you can use it for voltage, you can use it for current, you can use it to find resistance, then you can find some capacitance, frequency. So all of these things can be measured by using multimeters. But for wattmeter, you don't need you don't have a replacement. So wattmeter will be there, and measuring voltage and current, we will measure them using the multimeter surely. Okay. So Sudesh is typing his question. Meanwhile, I will explain the procedure. So the procedure here, first of all, we will perform the open circuit test. We will connect the input of the transformer to 20 volts. The output terminal are open circuited, which means that no load is connected to the transformer. Then we will measure the input current, power, and also we will see the output voltage, that our transformer is working correctly or not. And then we will perform open circuit test on the transformer. Sorry. Okay, so this I will just do a correction over here. So then we will perform the short circuit test. Okay, so this is saying that we have net problem. So this, don't worry, I am also recording this lecture, and this lecture will be available on YouTube. Okay, and you can see that there. I'll just type a message as well for him. Yes, I will give you the link to this. First of all, we have to finish this class. Then once it is recorded, then I will upload it. So you will get the link, inshallah. And the link of the previous lab is also uploaded on your Google Classroom. And I have also shared with you on this Skype group. So you can also click on that and review that lab as well. Okay, so this is saying thank you. So welcome to this. Okay, so we'll proceed now. So to perform the short circuit test, we will short circuit the output terminals, and we will connect ammeter to the both the output or the secondary. So you can see that here we will just add a ammeter over here. Okay, and then we will reduce the AC power supply to 0, and then gradually increase it up to the current of 1 ampere. Okay, so this 1 ampere is actually the rating of your secondary. So we will be looking at the secondary. Okay, so this is asking for Google Classroom code, so I will share it after this after this lab, and any student, if you have, so you can share it with him. And then we will measure the input short circuit current, input voltage, and power. Okay, and then we will increase these values, and also we will draw a graph for efficiency and load current. Okay, so as we cannot access our lab in this condition of partial lockdown, so what we will do now, we will perform this lab using multisim. So for open circuit test, you can see the diagram of multisim here. What I have done, I have connected a AC power supply of 220 volts over here, and then we have a multimeter which we are using as a voltmeter, then another multimeter we are using it as ammeter. This is the wattmeter, and connected to the primary of the transformer, and here we have connected a voltmeter to the secondary, and these values can be shown here. This is the voltage, and this is the current, and these are the watts. So this is a simple open circuit test, and the open circuit test will be there will be only one value, because there is only one rated voltage most of the time, so that's why we will have only one reading. Then we have a short circuit test. So in the short circuit test, again we will reduce our voltage over here, and we will connect a voltmeter, an ammeter, and a wattmeter again. Now this will be changed, there's a mistake here. Okay, this will be 50 ratio to 20. So we will alternate this power supply, this transformer, and then we will record the values here, and then we will note these values in our tables. These are 3 tables. I will explain these tables when or I can just explain. This is the first one here. This is the table for open circuit test. We will have some current here and some watts. So these watts will be actually our core losses, and then I have input some value, 1 volt, 2 volt, 3. What we will see that what is the rating of transformer. So according to that we will gradually increase our volts. We will have some currents over here and some power as well. So this power will be basically your I square R loss. Okay, so this power will be your I square R loss, and this power will be your core loss. Okay, then there is a table for efficiency, and as we know that our transformer, the secondary of our transformer is rated at 50 volts, so this VL will be 50. Then we will have some load currents. Load current will be actually the value of current on the secondary of the transformer. These will be your load currents. Okay, and from these currents we will have some output power, and then we will add this output power with open circuit losses and short circuit losses, and we will get the input power, and then we will calculate the efficiency. Okay, and then graph. So what I'm going to do now, I'm going to, first of all, I'm going to erase all these things, and I'm going to open the multisim now, and I'm going to make the diagrams on multisim. Okay, so let me open the multisim here. Okay, I will also open the slides there, so you can just get a view of the circuit diagram. So first of all, we are going to perform the open circuit test. So for open circuit test, first of all, what you need is actually a power supply, a single phase AC power supply. Just click on place, click on components, and then you will see a lot of components over here. Just click on this group and go to sources. So in the sources, then you will click on AC power. You can simply click here, or just you can click on power sources and you will get the AC power. Click on OK. Here you go, you have got your AC power over here. Then we also need a ground for our circuit, so click on ground, click OK, and here you go, you have got the AC power supply and the ground. So both of the values, both of the required components are here. Then I need some meters, so just click on the multimeter. You can see on the right side we have a block for multimeter. Click on that block and just you can gather 3 multimeters over here, because we need two multimeters for current and voltage of the primary, and then we need okay, voice not coming. Okay, I hope now it's clear. Okay, Yasin, now can you hear me now? Okay, that's good, that's good. So I will just repeat the procedure. If you had some issues with the voice, I will just repeat this procedure. Okay, so I have just opened the multisim, and on multisim I am going to make the diagram for open circuit test. Okay. So okay, that's good now. Okay, so on this multimeter, sorry, on this multisim I will make this diagram. So first of all, click on place, click on components, and in the components you need AC power supply. Okay, so you will see a lot of things over here in this library, and if you need sources, the power supply, the AC power supply is actually a source. So click on, okay, again my voice is not coming. Okay, now it's okay now. Okay, someone just muted my. Okay, so just give me a second. Okay, so let me continue. Now okay, I have figured out the voice problem, and I hope this will not be happening again. So okay, now what we are going to do is we are going to make this diagram, the circuit diagram on the multisim. So click on place, click on components, and first of all we need the AC power source. So click in the group sources, and then click on power sources and click on AC power. So as you can see, we have placed our AC power supply here. Next we also need a ground. So click on ground, click on OK, and here you go. So we have placed our power source and we have also placed a ground over here. Next we need a few multimeters. So on the right top you can see that there are a few multimeters. So multimeter, wattmeter, they are available on the right side of your window. So there's a separate toolbar for it. So we need 3 multimeters over here. Two multimeters for the primary side. We need to measure the voltage and current, and 1 multimeter for the secondary side. Okay. So this is also typing something. Okay, voice quality is poor. Don't worry if you are not getting the good internet reception. I am recording this lecture and this will be uploaded on YouTube as well. Okay, if you are having internet issues, it's okay. I will just change my connection. Okay, it's okay. So there's I will just upload these lectures on YouTube and you can go through them. So I request after the call, please share. Okay, Brar, we will, okay. I will upload these videos on YouTube. Okay, so coming back to our our multi-sim diagram. So what I have done here, I have placed a power source, 3 multimeters, and a ground. Next, I need a transformer. So again, click on place, click on components, and then click on all groups, or just click on basics. And in basics you will see transformer. So the type of transformer we need here is configurable 1 primary and 1 secondary transformer. Just click OK, and here it is. So next we need to configure our diagram, connect our diagram according to the circuit given, and also we need to configure all the components of our circuit diagram. So first of all, the power supply, I told you that the power supply will be at 220 volts. So just double click on the power supply. I will repeat it. Double click on the power supply and change the voltage to 220. Then click on frequency and change it to 50 Hertz. Click on OK. So first of all, we will connect a voltmeter to a supply. Just right click on this multimeter and click on rotate 90° clockwise. So multimeter 1, we will be using multimeter 1 as a voltmeter. So here we are going to connect this. Then there is an ammeter connected. And we also have a wattmeter. So see, on the right side you have a toolbar and you can connect this wattmeter here. So in the wattmeter you can see that you have two connections for V and two connections for I. So V is the voltage and I is the current. So the voltage or the voltmeter will be connected in parallel or across this power supply, which means that one end to the positive and the other to the negative. And the ammeter will be connected in series. It means that this one. It means that the input will be given to the positive of the ammeter and negative will be given to the transformer. So now we have completed the connections for the primary side. You can also change the color of these wires. So the upper portion is of the phase, so that will be red. And just select the wires in the lower portion. Click on right click and then click on net color and change this color to black. So now you can differentiate between the phase and the neutral connections. We also have to configure our transformer. So just double click on this transformer and then you can see the values. So as you know that the primary for the open circuit test will be 220 volts and the secondary will be 50. So when we configure the number of turns, we are actually configuring the voltage for primary and secondary in multisim. Click on OK, and now you can see 220 to 50 ratio. Also, how you will configure that or how you will know that which side is primary and which side is secondary. So you can see a dot over here, and this dot is actually representing the phase of your primary winding. So this means that this area or this connection is the phase of your primary of this transformer, and the other connection is the neutral. And the similarly the opposite side here, this is the phase of the secondary, and this one is the neutral of the secondary. So in the secondary side we just have to connect a voltmeter. So again, right click on this multimeter and rotate it clockwise. So here we go, connections are complete. Again, I will change the color for neutral to black. Now we also have to configure these multimeters. We are going to use it as a voltmeter or a multimeter or a ammeter. So double click on multimeter 1, and now you can see that there are multiple options: ampere, voltage, ohms, and decibels. So we are going to use the multimeter 1 as a voltmeter, so click on V. And then we also need to select the type of voltage supply. So this one, the sinusoid is for AC and the straight line is for DC. So we will select AC because transformer operates on AC power supply. Then double click on multimeter 2 and select A and sinusoid. For the wattmeter, there are no configurations. It will automatically sense your signal and give you your power. And then the multimeter on secondary side, we also need to configure it to volts and AC. So our circuit is complete now. Just click on play or run and circuit will be simulated. So as you can see, we are supplying 220 volts to the transformer, which has been stepped down to 50 volts. As far as the transformer is considered, there is no load on the transformer. Connecting a voltmeter means that the circuit is still open because the resistance of the voltmeter is very high. So therefore no current flows through the voltmeter. But still you can see that there is some current flowing in the primary of the transformer, and therefore with that there is some power loss in that transformer. So this is the power loss, which is 2.550 microwatts. So it is not a big amount, but still it is a power loss, and it will affect the efficiency of our transformer. So now what we will do, we will note these values over here in the table. So input is 220 volts for open circuit, and the current here is 39.425 microamps, and the power recorded is 2.550 microwatts. So this power here, 2.550 microwatts, is the core loss. Okay, I will just write it here. It is the core loss of your transformer. Okay, so next we are going to perform the short circuit test. So for short circuit test, first of all, what we need to do is to reduce our voltage to minimum voltage. I'll go for 0.1, and then the transformer, we have to change the primary and secondary. Now the primary will have 50 turns and the secondary will have 220. Then we need to change the voltmeter connected to the secondary to ammeter. So just click on A and you have configured your circuit. And this is the diagram which was shown in your circuit diagram. Just have a look here. So you have a single phase supply, you have a ammeter, you have a wattmeter, and then you have a ammeter on the secondary side. Okay, so let us just get on with it. Now there's a lot of power going through it, so there's a short circuit, but we need to also connect a resistance. Just click on components, click on basics, and click on resistor. Place any resistor over here. Because this is a simulation, so a lot of power is going through it. So just connect, just make this resistance to 1 ohms minimum resistance. Okay. So now you can see that at a very low amount of voltage, a large amount of current is flowing through your circuit, which is 1.936, and the secondary is at 440 milliamps. So actually what we are going to note here are the values on the secondary side and also the values on the primary. So I will reduce this current to 0.05 or 0.05. Okay. So now this is the first reading. We have supplied 50 millivolts input, and we are having current flowing through the primary of 968 milliamps, and the total power we are calculating here is measuring here is 48 milliwatts. So I will note these readings on the table provided in PowerPoint. Okay, so first of all, the short circuit voltage and current, also the power. Just remove these values. So 50 millivolts, and the current is 968 milliamps, and the power is 48.4 milliwatts. And the reading over here, which is on the secondary, we are going to enter that reading to load current. So here it is 220 milliamps, and this 50 and 220 milliamps will make your output power. Next, I will again increase the voltage to 0.1 volts and run our circuit and note down these values. Now the voltage is 100 millivolts, the current is 1.936 amps, and the power loss is 193.6 milliwatts. And note down these values of the secondary side to the efficiency table. Okay, then also increase the voltage again. अच्छा जी, there is a question, sir, आप उर्दू में लेक्चर दें कि हमें समझ आए. Okay, we will discuss that after the class. Okay, so 440 milliamps, and I have noted these values here. Then again we need to increase the voltage 0.15 here. Just run the simulation, and again we are going to note these values. So 150 millivolts and 2.904 amps, 435.6 milliwatts. And 660 is the load current, 660 milliamps. Then again we need to increase the voltage and record the values. So 880 milliamps, the voltage now is 200 millivolts and 3.872 amperes. Power is 774.4 milliwatts. Just the last reading, we have to increase the voltage up to 0.25 and then run the simulation and note down these values. 250 millivolts, 4.84 amps, and 1.21 watts of power loss. Now, why do I stop here? This is because the secondary of our transformer, or the 220 volt side of our transformer, is rated at 1 ampere. So when the 220 or the high voltage side of the transformer and the one we have short circuited has reached the value of 1.1, which you can see on multimeter 3. So this is the maximum current uh, we can flow through this winding. So this will be the final value. So now I will show you the calculations again. Now in the first table we calculated the core loss, and in the second table all these power is actually your short circuit loss for different amounts of load current. So I will just calculate value of efficiency for one case, and then you can follow this procedure. Okay, so first of all we have to calculate the output power. So output power can be calculated by multiplying the load voltage and the load current. So in this case 50 volts multiplied by 220 milliamps. So remember that 220 milliamps means that you have to multiply 10 raised to the power minus 3 first here. Okay. I'm just going to calculate it. So now this value becomes 50 multiplied by 0.22, which makes it 11 watts. So you can put the value of 11 watts here. Then you have to add this to the power of the open circuit, which means that the core losses, which is 2.55 microwatts. 2.55 multiplied by 10 raised to the power okay. So 10 raised to the power minus 9, okay, because this is a microwatt, so sorry, minus 6. Micro is minus 6. Okay. Then we have to add this power again with the short circuit loss. Okay, so we have a question over here. What is meant by okay, so next we are going to add the value of short circuit loss for 220 milliamps. So here we go. This is the short circuit loss, 48.4 milliwatts. It means that 48.4 multiplied by 10 raised to the power minus 3. So let me do the calculations. Okay, so it will just take a while. So 2.55 into 10 raised to the power minus 6. Okay, so it is around 11.0484. So now I'll put these values over here. So P out is 11 watts and divided by 11.04484. So this now becomes 99.56, and this is the efficiency of your transformer for this particular case. Okay, so this means that if you put a load of 220 volts 220 milliamps on your transformer, so your efficiency will drop to 99.56%. And similarly you can calculate all these values, and which you will be doing in your assignment. And then there is a graph. By increasing load current, what will happen to the efficiency, and then there is a conclusion. Okay, so that's all, and I will also take the screenshot of the attendance. Okay, so now you can open your mics and ask me questions. Okay.